Hello everyone, True Zero Emissions here. So I have this, I'll call it a polarity meter. It actually is for magnets, right? A magnet is a dipole, and I see it as cohered space, cohered into a plus and minus or north and south. That's what a magnet is. It's a material entirely made up of zero-point field energy, right? That's what everything is. The zero-point field sustains the material universe, and the material universe sustains the zero-point field. That's just the way it works. Here's what I'm looking at right now. What I'm looking at is I have these magnets here, and then I have these less powerful magnets here. What I want to see is okay, that's the Bloch wall, right? I'm looking for the Bloch wall right now. The Bloch wall, and please study this for yourself. I may not be describing this correctly, but I'm studying right now. This is my researching, and I'm a beginner. See how nothing's reading right there? South right there. At the third magnet, right? The third magnet in is reading south. The fourth magnet is reading nothing. And then we're north. The rest of the magnets are north, right? Okay, this is what I'm going to do. I bought that on Amazon. I think this is the one that John Bedini was using right here. But anything that measures north and south, that identifies the north and the south of a magnet, it will be fine. That's my understanding. Okay, I'm taking these magnets off. Okay, I just took those off. It's very dangerous to work with magnets. So if you are working with magnets, I know you know this already, but please be careful and never touch magnets. Never even go near them without wearing safety glasses on. I've had chips of magnet break off when they hit each other and flow right into my glasses. And it's a good thing I was wearing glasses. Let's see if it's still the same now. Okay, let's see if the third magnet in is still the... Okay, let's see if anything changed. So the third magnet in is still south. And the fourth magnet is 0. The fourth and fifth magnet are 0 right now. I think this is the sixth magnet. This is my first north. Okay? 1, 2, 3. The fourth is nothing. The fifth is no reading. And the sixth is our first reading. I'll put these magnets back in. It's grabbing my glove. It won't let go of my glove. There we go. Okay, so now the third magnet in is reading 0. Fourth magnet 0. Fifth magnet is north. That Bloch wall shifted. What I'm calling the Bloch wall. I think I'm saying this correctly. What I'm saying, what's important, we don't have to agree that's a Bloch wall. We don't have to agree on that. Okay, we don't have to agree on anything. Only thing I'm looking for is how can I charge a battery in the most efficient manner possible. That's the focus, okay? I see a lot of people getting stuck on the words. This word means this. You can't do anything else. You can only do what this word says. You know what? I'm looking for how to charge a battery. I'm looking for the zero-point field infinite energy to flow through these magnets. This magnet, all magnets are windows to the zero-point field of infinite energy. Magnets are polarized space. Magnets are space cohered into a plus and a minus. Did you see that shift? That shift, how we moved that where 0 was? Okay, I'm just going to make up words right now. I'm just making up words. Doesn't matter. what do I mean? I want to see where that 0 is, what I'm calling 0, where the meter doesn't do anything, where that meter that reads north and south, where it's not giving me a reading. I'm going to call that the Bloch wall, and I'm going to call it 0. And I'm going to call it the window to the infinite energy field, where energy just flows in endlessly, right? All the energy we need. Remember, the 0-point field has 10 to the 40th times more energy than the entire material universe. That's a fact. That's a measurable fact. Okay, this has all been measured. This is science. Just like plus and plus, just like plus is a minus, right? 1 plus 1, all that. It's the same thing. It's just like that. When that field shifts, right? Because what did I do? I added these magnets and it moved it, right? It moved where the 0 was, right? Now, if I can do that, if I can move that Bloch wall, if I can move that and I have wires wrapped around these magnets. So if I have wires wrapped around all these magnets, right? Regular copper wire, not even magnet wire, just regular wire. It might be more efficient with magnet wire. But if I wrap, the idea is if I wrap these magnets with copper wire, and then I move that Bloch wall, right? I move it, right? So that might mean, right now I'm thinking of a couple things. And I'll share those thoughts with you. See, that was very dangerous what just happened. That can make the magnets break. And if these were neodymium magnets that just smashed into that, they would have very likely broken to pieces, and they can throw the magnet. When a piece breaks off, it'll usually fling it out. And I don't know why, but it always throws it toward the person. I've always had the pieces of magnet fly toward me. So that's why it's important to always wear long sleeve shirts. I'm not wearing long sleeve right now, but just having glasses on is the minimum requirement. Safety glasses, and a face shield's actually better. So this magnet wants to attract here, right? I'm using the side that wants to attract, because one side wants to attract and one side wants to repel. So that could be tested as well. I could see what happens if I put the repelling side there and see if that Bloch wall moves, right? I don't know see, what I'm talking about right now is having this magnet on a wheel where it goes in a circle, right? And this is mounted in one place with the copper binding on it. And this goes past that. It goes past it. And when it passes by here, it shifts that Bloch wall. It shifts that 0 field. It shifts where the magnet reads 0. It doesn't read north or south. It's in the middle. It's a neutral area. When that shifts, the magnet, my understanding, my research and study indicate that the magnet can induce, I'm not sure I'm saying this correctly, but it can cause the coils to receive a voltage and a current, and we can do things with that current and a voltage. Don Smith made something called the rotating separator coil, and he was doing it a little bit differently. He had 2 sets of magnets, like this is one set, and he had another set of magnets, and they were neodymiums. They were very strong. He had them, I don't know if it's 1 inch apart or 2 inches apart. I don't know how far apart they were exactly, but they were attractive, right? So north and the south, they were trying to come together. And he held them apart from each other with something he made out of wood. And he would have a pair, he called them pairs. And that one pair of magnets, which is probably 2 inches in diameter by 6 inches long. So 2 of those, right, trying to come together, wrapped with regular copper wire. So the same wire going around all these, and then over, and then around all these, and then going to, I'm guessing, a full wave bridge rectifier, or diodes, just to convert it to DC, right? And then that can be used in a battery, right? That's my thoughts. But he was getting 1,000 volts at, I think, 40 amps. 1,000 volts at 40 amps. Now, if we multiply 40 times amps times volts is watts, 40 times 1,000 is 40,000 watts. I only need like a couple, I just want to have a couple hundred watts. I would like to trickle charge my battery on my scooter while I'm riding it, which means while I'm not riding it and there's no load on the battery, and it's a lot easier to charge a battery that doesn't have a load on it, right? This trickle charger, which is putting in a couple hundred watts, can help put a little bit of charge back in the battery. Now, I know to charge a battery that has a load on it, like if I'm pulling 1,000 watts from this scooter battery by going fast, and then my Bloch wall generator, if I call it that, if that's putting energy into the battery, I'm just going to have to test this. And here's what I'm watching. I'm watching battery temperature. Someone was telling me they were really concerned for my safety, because they said, I'm paraphrasing here, they were concerned about the battery getting damaged. They said, you're going to be putting so much power in there. And they were concerned. They were concerned. But what they don't realize, and I didn't say this, but I couldn't stop smiling, because my whole focus was on how much energy there is, right? All I could think of was, wow, if there's that much energy that I can actually damage my battery, I would be happy to replace the battery. I would just be happy that I have that much energy. But of course, if I'm getting 1,000 volts at 40 amps, if I was getting that's not what I'm trying to do. I just want a few hundred watts. But if I was able to get a really high number, I think I could limit the power by going with smaller magnets, less wire, and less RPMs of the system, right? So if it's magnets changing the Bloch wall, then not spinning this as fast, right? Just spinning it at a slow speed, right? Some numbers that were being considered was like 60 times a second, right? 60 cycles, get 60 pulses. That's a number that is my research and study indicate that could be useful. But if I was getting 1,000 volts at 40 amps at doing the 60 cycle per second frequency, if I call it that, then I could just do like 3 cycles per second instead of 60, or 1 cycle per second, right? And see if I'm still getting some voltage. Store that in a capacitor, and then have it go to the battery, right, to help smooth it out. But it would have to go to a full wave bridge rectifier first to convert it from AC to DC, right? Yeah, I feel comfortable with putting a pulsed DC into a battery after studying gbatteries.com and seeing what they're doing. It appears that they're using really high voltage spikes, and I know that high voltage spikes have current. Every voltage spike delivers current before it delivers voltage. So knowing that, I mean, I would just be watching temperature, and I know that G batteries is not, from my understanding, is they're not having any trouble with the batteries warming up. My understanding is they're staying very cool. They're not getting hot. So yeah, so here we are. And some of the thoughts are, do I want to take a magnet and pass it by there I'll put it mounted on a wheel and have that magnet mounted on another part, maybe mounted on wood or mounted on something that can hold it, maybe even in a pipe like Don Smith did, right? Donald Lee Smith. And I do recommend this book here. It's the Don Smith Magnetic Resonance Energy Crafting Systematic Index book. And that book is, it's very helpful because it has a lot of information in it, right? That book has a lot of information about the experiments that I'm conducting, and it's really a significant foundation for for my research and study. It's a significant part of the foundation. So but if you just want to start experimenting, the information that I shared with you today, based on my research and study, about shifting this zero field where the magnetic pole detector reads that zero. I don't know how that could be measured without that, although I'm guessing that another way of doing it would just be to wrap magnets with coil, with wire, and then just pass a magnet past it, and just see if we're getting anything out of the wire, if anything's happening there. I mean, I think Don Smith was the master of efficiency, but what frustrates me is trying to understand the puzzle. I really feel that it is the puzzle of what he's sharing. But I know some people are really good at puzzles and seem to understand things without even looking at them. I mean, I can talk to people sometimes about things I'm thinking about. They seem to already understand thoroughly everything that I'm both thinking about and have not yet thought about. I just think to myself, how could that be? It's so amazing, you know? And someone like that experimenting, I think, could make rapid progress in these kind of experiments if they were interested in doing these experiments. My interest is in charging my scooter battery while I ride the scooter. And if that's a trickle charge, that's fine with me. I just want to put some energy back in there. I already started years ago with solar, and that worked very well. And it's funny because the people that, before I did the experiment, a lot of people said, you can't do that. If it could be done, it would already be done. It already is being done. It's schools are doing it all over. They have competitions where there's even races where people race with their solar bikes. I don't know how to find it, but just put like solar bicycle race or electric bike or solar bike race. They race all over the world. These races are always taking place. Yeah, so I was pulling a couple hundred watts worth of solar panels on my electric bike or my electric scooter that I had years ago. And I was able to keep the battery full all day. And yes, on that scooter, I was charging the battery as I used the battery. But there's also times I would stop and just be waiting for a red light or talking with someone about the scooter because people were so excited about it. And the scooter would be charging all that time as well, just all the time that I was sitting there. But this system is a little different because now we're using magnets, which are just, I've heard them called sponges for the energy for electrons and electron pairs generated by the sun, right? So the electron pairs coming from the sun, and these electron pairs are absorbed by magnets, and magnets recharge themselves as long as you don't drop them or get them hot, right? These have to be kept cool. So that's another factor, is this process, once this is working, the magnets will heat up, and there has to be a way to keep them cool. So I don't know if that would be just having fans running on the magnets to help them keep cool, but that's very important as well, is keeping those magnets cool, because as long as they're kept cool, they will continue to replenish themselves endlessly. And if someone wants to debate the exact lifespan of a magnet, well, if this magnet could charge my scooter for 100 years, I would be happy with that. And if I had to buy magnets after 100 years, I would still be happy with that. And I'm not looking for perfection. A lot of people that are against very, very efficient technologies or anything new that's not considered like mainstream, even though free energy is completely mainstream now. But I'm just saying, if that was the case, that someone said, well, if someone doesn't feel comfortable with free energy, I mean, that's just, I don't know what to say about that. I mean, to me, I'm just kind of focused on charging a battery. That's just where my thoughts are. So anyway, everyone, hope you have a great day, and I'll keep you posted on the progress of this experiment as I progress through it. But I did see how that, and I know you saw here, and if you didn't recognize or notice it, just go back in the video. But notice how I'm adding these magnets here, even though these are not as strong as these, but by adding these to the end, it caused that field to shift over. It seems like it pulled the zero area this way, right? By having this here, it pulled it over this way. So if I pass this past here real quick, that field would shift, and shift again real quick. It would pulse, like it would move like this, boom, right? It would shift this way, a couple of these magnets over, it would shift, and that movement, I think, is what we're looking for, and that's what the copper wire will, I think, that's what will cause the copper wire to somehow allow a voltage and a current, right? A voltage and current to show up in that copper wire, and it's coming from the magnets, right? Or it's coming through the 0 point field, through the magnet like a window, and into the wire and into the circuit. Okay, everyone, True Zero Emission signing off. Have a great day.